I'd like to briefly explain the solution behind path sum. And if you read the description, it's apparent that it wants you to essentially return true if there exists a path in a tree that essentially the values of the nodes along that path add to a particular sum. So as you can see here, the sum that was originally passed in was 22. And so we've 5 plus 4 plus 11 plus 2 is 22. And so there does in fact exist a path where the sum is what was passed in for the target sum. Now, the ideal solution for this problem essentially is founded on sort of a claim. And the claim is that if you pass, so when you pass in the original target sum, what you want to do is you want to subtract the value of the root and then pass that value down to the next node in line. So that may sound confusing. So what you end up doing is you do, you basically, you take the sum and you subtract 5 and you pass that value to 4, and then 4 does the same thing, and then 11 does the same thing, and then 7 does the same thing. So basically what I mean here, so you passed in 22 initially, that was your target sum. You subtract 5, and from that you'll get 17. So you end up passing 17 down to the next node in line. And so now this node does the same thing except with 17. So now you end up doing 17 minus 4, and it passes that value down. Now what's 17 minus 4? It's 13. So you end up passing 13 down. And then this node does the same thing. So you end up doing 13 minus 11, which is equal to 2. And then you pass that value down too. Now the claim here is that if you do this from the root to the leaf of a particular path, if you come to a point where the sum is equal to root.val, where the sum is equal to the value of the leaf node, then that path, the sum along that path is in fact equal to the target sum that was originally passed in. And that should make sense because for the very last value, if the sum that you passed in is equal to the root.val, then the sum that you passed in minus root.val is 0. You've diminished the original sum by subtracting all the values along the path. And for a valid path, you should expect a 0, or you should at least expect that the value at that root is equal to the sum you passed in. Now, as you can see, for 7 here, if we do this, so first it was 22 minus 5, we got 17, we passed 17 down. Then it was 17 minus 4, we passed, which is 13, we passed 13 down. And then it was 13 minus 11, we passed 2 down. And we see that 2 minus 7 is not 0, or the sum is not equal to the root.val. And so, we backtrack a recursive. So we don't backtrack necessarily, but we take a step back and we return false for this particular case. So we move forward up one more. We hit a base case. The root is null, and then we end up returning false. So, but see that. So that's the claim, right? That's the claim. Now we'll see how this works for each node. Although we already kind of diminished the original sum, I showed you that on the board. But okay, so you pass in, so you have a root and you pass in the target sum, and none of these base cases are met. And so basically you say, okay, well, you're going to generate a Boolean from the left. So each of these nodes is going to be waiting on a verdict. And the verdict is, does the right give you a true case, or does the left give you a true case? Because remember, what you're really, you don't really care if, you don't want an and % here, because you only want one particular subtree to have a valid path. Either, if we think of this node, either this node can have, the path that we wanted, or, the right subtree could have a path that we wanted, right? So it isn't the case that they both have to sort of join in from both sides or whatever. But nevertheless, so we can think of this as a two-step sequence here, where one is it gets a verdict from the left, and 2, it gets a verdict from the right. So the first step is to get a verdict from the left. So it passes in root.left. Okay. Now this guy's also waiting on a verdict. the first node in line is processing its first step. It's trying to judge whether or not the left gives a true value or not, or what the verdict is from the left. And then so it passes. So what it does, so what we do here is we take the target sum -5 and we get 17, right? So 17 is passed in as a value, right? So we've passed in the left and we've passed in the target sum -5. So we've passed in 22 or 17 rather. And now it's processing its first step. So we again come into the recursive call, and now we're processing. So 4 is now processing its first step, and so 4 does the same thing. It passes the left, and for that node, for that particular call, it just does 17 minus 4, which is 13. Okay, so it's passing down 13. And now we have another recursive call. So 11 sort of restarts the story here. And it also passes its root.left. And then it does, okay, what's its target sum? We know it's 13. 13 minus its own value, which is 11. So it's 2. Okay. And so, 2 is being passed. And of course, it has its own series of steps. So now it's processing its first. It's waiting on a verdict for the left. And again, we pass down 2 here. And so 11 essentially passed down its root.left and 2. And so for node 7, is node 7 null? It's not. So we don't return false. Is it a leaf node, right? Is the root.left and the root.right null? Well, certainly it is, right? And so it is indeed a leaf node. Is the target sum that was passed in, is that equal to the value? Is the sum that you passed in just now equal to the value of the leaf node? It's not. And so so we basically, since it's not, we continue, right? Okay, this is not a valid choice. What we know is that eventually we're going to traverse to null. And so, you end up passing root.left, which is null, and you do target sum minus root.val. Again, that's just redundant. But when you come up here for 7 and you've passed in root.left, you hit null, you return false. So what's happening now is, you've shot back up a false verdict. So 11 was waiting on what the left subtree verdict was. It's false, right? And then immediately after 11 is done processing its first step, it now starts processing its second step, which is to determine whether the right subtree has a solution. So it jumps to the right. And remember what 11 passed in as a parameter. 11 passed in 2 as a parameter. Okay, that is what its recursive call passed in. And as we can see, so when you process 11 and you come up here, is the value, the node that you passed in null? It's not. You don't return false. Is it a leaf node? And yes, it is a leaf node. Is the target sum equal to the root.val? Yes, it is. The value that you passed in, which was 2, right? For 11, you passed in 2, and as you can see, the target sum is equal to the root.val. And if you were to subtract them, you would get 0. You could have also said target sum is minus root.val is 0. That could be a very similar check. You've diminished the sum across this path. And so we end up returning true for this node 2. So what happens is we shoot up the true verdict here. We shoot up the true verdict. And so here for 11, we have false from the left subtree, and we have true from the right subtree. And remember, we had an or operand. So we just wanted to return whether either or were true. And it's the case that either or are true. One of them is true. The right subtree gives you a true solution. And so now you shoot the true verdict up to 4. 4 was processing its first step. Now it's trying to see, 4 was processing its first step. And then it starts process. So it gets true from here, right? And whatever it does for the second step is sort of irrelevant. It goes to the it goes to its right, because it has to process the second step. It goes to its right, and then it shoots back up a value false because it's null, right? But it doesn't matter. True. What we said was either it can T or F, right? And since one of them are true, it's true. So it also shoots up a true verdict. And remember, 5 was waiting on what it has from the left or right, and we know that this is true from the left, that there is a valid solution in the left subtree. And it could start processing the right subtree, but remember, we would return true if only one of them were true. And since the right subtree holds a solution, we end up returning true. So it bubbles up a value as soon as it hits. So the main idea here is that you're diminishing the sum, and then you are traversing the tree in an in-order fashion. And as soon as you come across a path that has its sum equal to its root value, you just you basically bubble up a true verdict, and then all of these will basically say true. And then eventually, when you do a method unwinding where you start unwinding the recursive stack call, eventually you have true at the very end.